Welcome back to the Foundation in C# course. We're currently in Module 7, and in this lesson, we're going to be covering one of my favorite project types, and that's ASP.NET Core Web API. And we've talked a little bit about Web API before, but Web API is a way of sending data to various applications, to and from various applications. So it is a user interface type, but it's a user interface for not necessarily people, but for other applications. Although you can look at it through like a web application or even a tool like Postman. So let's get started in Visual Studio. We're going to create a new project, ASP.NET Core Web Application. We're going to call this let's call it Message Wall API. How about that? And Message Wall API app. And we get to select our project type. There's a number of types here, but one of them is just API. We used to call it Web API. So if you hear Web API, it probably refers to .NET Framework, although I still kind of carry over and still call it Web API because it's a website and it's an API. But this is the API type in ASP.NET Core. So I've got .NET Core, ASP.NET Core 3.0, API. I won't have authentication on here, but I will add HTTPS like normal, and of course no Docker. Hit create, and this page is the same as any other ASP.NET Core page. Let's close that out and look at what we have here. And it's a little smaller than even MVC or Razor pages. But this is an ASP.NET Core web application, which means we can add in Razor pages or we can add in MVC without much difficulty at all. They're basically just settings. And if we look here, we see dependencies like normal. We see our app settings, which just has our logging information and allowing all hosts to connect to it. We have our program.cs, which has the same exact setup as our Razor Pages application or MVC application. And we have our startup, which is pretty close to the others. There's just a few tweaks like add controllers here and map controllers for the endpoints. That's pretty much it. And it does have this weatherforecast.cs class added. And this is essentially it's a model and it's just used for demo purposes. So let's look at the controllers folder where the things are different. And this is the weather forecast controller. So this is an example for us. We have here, first of all, it's marked as an API controller and inherits from controller base. And the route is controller in square brackets, which that just means the route is /weather forecast. Okay, so that's the route. And then inside here, we have some read-only data. This is just sample data. We'll set up a new endpoint so we don't have all this sample stuff, but it's good to see. Then we have our logger, which of course you've seen before, and also the constructor that asks for an iLogger. Cool. And then we have an HTTP GET. And what this does is it's just the GET call for /weather forecast. And so you call it /weather forecast, it's going to call this GET by default since your browser issues a GET call by default. It doesn't do post calls by default. So therefore, it's going to get some random weather information and it's going to return that random weather information as an IEnumerable of type weather forecast, that model we saw. Let's just run this and see what happens and what it looks like to run just an API. Now notice by default, it called the /weather forecast. If I didn't do that, I get this page can't be found. There's nothing here. But if I do my /weather forecast, it returns this data. And let me zoom in here. So I'll zoom in like so. And notice this is JSON data. If you're not familiar with JSON data, it's JavaScript object notation. And what that means essentially is that it's just a way of displaying data in a text file. So the square brackets indicate an array. The curly braces indicate an object. So there's an array of objects here, and this first object, and it's not formatted very nicely. We can look at that in a minute. But it's got a few properties. Date, and here's the date. Then it's got temperature in Celsius, and that's 51. Temperature in Fahrenheit, and that's 123. It's a little hot. And the summary is that it's mild. I don't think 123 degrees Fahrenheit or 51 degrees Celsius is mild. That might be a bit on the warm side. But that's one object. And then notice there's a comma afterwards, and then the next object, and that's this object right here. And so it's five, let's see, 1, 2, 3, 4, and 5 objects here that it's returned. Now, this is definitely not something you want to show to users because it's just not useful. However, if you have any application that needs data, this is an amazingly easy way to go. Because now you have a data, actually C# can convert this data right back into objects. And so if you have a totally disconnected application that, let's say, has a WPF front end, or it has a MVC application, but it's on a different server, or you have a mobile application, they can consume these endpoints. They just need to call the URL/weather forecast and get the weather forecast for the next 5 days. Which, of course, this is all fake data, but that's what it would do for them, is they get the weather forecast very easily. And they just ask for it, they get back these objects, they can convert those objects back to C# objects, and away they go. So I think this right here, before we go any further, I think it highlights the benefits of the API project. And that is that you can kind of hide all of your business logic, you can hide all of your data access code, all that stuff behind an API, and then any user interface you want can get that data, but through your business logic and through your data access in a way that's safe and secure. An API does not have to talk to a C# application. This is not Microsoft specific stuff. The web is full of APIs. In fact, most applications of any size have some type of application programming interface or API. So if you decide to write your application in, let's just say, Swift, which is what you'd write a native iOS app in, or iPhone app, you could write it in Swift and call this API. If you decide, you know what, I really want a Java front end, cool, go for it. Write a Java front end and call this API. If you decide, I've got some old school stuff that's actually VB6, as long as it can talk to the web, it can call this API and get the data back. So really, your front end can be anything you want. I have written front ends entirely in JavaScript and talked to a C# web API, and it's wonderful. I have all of the business logic and all the data access code and all the stuff that we might call back-end coding stuff. All that lives behind a wall, and that wall is the API. So if you haven't realized it by now, I've saved my favorite programming front end for last, and that's the API. I really am a huge fan of API. So let's look at what the different pieces are. And really, for this controller, all it is this get call. So when we did the /weather forecast, it said, well, I want an HTTP GET call, therefore controller base. The route for this one by default is API/controller. Remember I said that if you have an MVC project, you can add in an API as well, and then typically the routing is API/something. Well, that would enable this to happen because by default it's API/the controller name. If you take API off, like the weather forecast did, where it's just controller, the only downside of that is that if you have a message wall razor page, that would conflict in routing with the message wall controller, which is why Microsoft's convention has been that for APIs, everything starts with API/. I'm not sure why they didn't do it over here. ID passed in. We have a post and we have a put and we have a delete. I'm going to leave them all here just for now so we can have those examples, but let's go ahead and create or modify what we need. Now what we have here is our get call, which this is going to return an IEnumerable of string, a list of string. So what I'm going to do is I am going to leave alone. I'm debating if I leave it alone or not. I think I'll leave it alone. We'll just do demo for this. But this returns a number of values. Let's not leave it alone. I can't help it. List of string. We're going to call this output equals new list of string. And we're going to start off with hello world and how are you as the two strings in that list. Now normally we'll return output. And I can return output, which is a list of string, even though it asks for an IEnumerable of string, because a list implements IEnumerable. So a list is an IEnumerable. So I have these two objects or two strings in here already. But what if I wanted to make this get where it optionally had a value you passed in? What if I said string message? I'm going to say string message equals empty string. I'm going to say if string dot is null or white space message equals false. So if it's not a null or empty message, then I'm going to say output dot add message. So if you call this get with a parameter called message that has a value in it, then I'm going to add that to the list. Let's run this and see what we get. Just slash message wall. So slash message wall with nothing else. And it says, nope, can't find that. That's because it's actually slash API slash message wall. We get the hello world and how are you. But what if I say question mark message equals goodbye. Hello world, how are you? Goodbye. So now I've passed a basic message through the get command, and it has put it on the list and returned that value too. That's a simple way of doing things, but that can get messy really quick. So if you said goodbye to all of my friends, that's an ugly URL with spaces and everything. And it fixes it for you. It puts the %20 inside wherever there's a space, and it actually, decrypts that back to a normal string. So goodbye to all my friends. So that works, but obviously this gets pretty tedious after a while if you have a lot of information to pass through. Not to mention the fact that every time you post it, every time you hit go on this, it's not a post, it's a get. Every time you call this URL, anything that logs URLs is now logging your message as well. And that's not ideal. So how do we get around that or deal with that? Well, we decide that we're not going to do it with a get. Instead, we're going to do it with a post. And so the post is going to have a message. And typically posts don't return a value. That's why the void. They just say, yep, I did that. That's pretty much all it is, and it returns a success status message. So with this string, we could, let's just say we're going to do a logger, which we don't have a logger yet. Let's create one. Remember how to do that? We're going to say C2R for constructor, and we're going to ask for an iLogger, control dot to add that using statement. And the logger is going to type message wall controller. We're going to call it logger. And then down here we'll say underscore logger equals logger. You may say, Tim, we don't have an underscore logger. Sure enough, we don't. But if you do control dot, we can generate that private field called logger. And notice it does that for us right here. Just note, you don't actually have to have this. So that is also acceptable. Either one is fine. But down here now, we can say logger dot, and let's just do a log info or log information that says our message was, and let's just say message. And pass in the message. And if you've watched AMI information on logging in C#, that's a totally different subject that's not really covered in this foundation course, but I do have content on it. What's happening here is I just gave us a name. I called it message with a capital M. And that's going to be the first variable in this list. These names do not have to match. It's just order-based. So a second thing in curly braces is the second variable I pass in, which I don't have one right now. And so on, even if it was messaged twice in a row. So this just puts this in this spot. But the reason it does it this way is because certain loggers can actually pull out this value and store it separately from your message. So with a date time, they can actually query on that date time. Or if it was a value for an order, let's say a dollar amount, they could query on that separately from your status message. So with this way, we can just put a breakpoint here and look at the message. So we're going to run this, and we want to do a post, not a get. Well, how do we do a post? So this is a get command. That's not what we're trying to do. How do you do a post? Well, you can't really do it in your browser like this. Instead, you have to use a tool like Postman. And this is the tool that I use. And you can get this from the URL getpostman.com. So Postman. So getpostman.com. And this is a free tool that's really powerful. It does a lot of things. And one of them, if I hit the plus right here, is I can paste in this URL, but I can say, actually, I want a post command, not a get command. Notice all the parameters or different types you have here: get, post, put, patch, delete, copy, head, and all the rest that you probably never even heard of. So post command, and now we can set up our values in our body. Because remember it said that it comes from the body, and we're going to say that this is, I believe it's going to be raw. We'll see in just a minute. But if we say not text, but I want JSON, remember the JavaScript object notation? So I'm going to say that the message is going to be, hello, my viewers. That sounds good. Now remember we have a breakpoint over there. If we click send, let's see what happens. We could not get a response back. This is an incorrect call. So we're not making the correct call. Let's do instead, I'm going to grab us and copy it, the form encoded, just to see if this is it, and say message, does this work? And hit send. Nope. Actually, I think what the problem is, I was right the first time of the raw and the JSON. I'm fairly certain. But if we read this message down here, it says self-signed SSL certificates are being blocked. Fix this by turning off SSL certificate verification in Settings General. So if we go to the settings and go to General and turn off SSL certificates verification, it should be, hey, that's having a problem with validation, but we at least got a little farther. And the reason why is because we're using a SSL certificate that is generated by Visual Studio. It's safe for testing, and it's something that allows us to test SSL in development, but it's not something that is a true certificate you trust in the real world. Postman is worried about the real world, but when we're just testing. Okay, so the issue here is we're passing in an object when really I think all we need to pass in is the string because it's not an object, it's just a string. And if we send this, let's just try sending it as text. And hit send. And it says unsupported media type. And the let's just add one just to show you two values. And in this case, the message is a message model, not a string. And then it's going to be message dot message. We're going to log. We're going to look at both of those values. Now with this in mind, back in Postman, go back here, we can look at calling this. We'll actually got to restart this. So let's restart this. And while it's starting up, it is body, JSON raw. So set up raw and then JSON. And then inside here, we're going to have our curly braces, which that was so helpful to do that, but it's not what I wanted. I'm going to have the message be colon and then hello my viewers. We're going to have an ID as a colon 20. find an ID, but want to get just one message from the message wall, pass in the ID, and we'll get you just that value. That's not unsafe data. That's fine to have for anybody to have. So it's no big deal. But if you want to send data that is in any way sensitive, a post command like this puts this body in the encrypted body where no one can read it. So that's how you use Postman with API to test those things, and it can take some trial and error to get it right, but with that, you can have some pretty impressive stuff reading and writing through this middle tier layer. So that's all Web API is. I mean, it really is simple. There's no HTML, there's no CSS, there's no pretty display. You could add stuff like a Swagger UI, which will show you all the different endpoints you have and how to call them. But really, an API is just for computers to talk to computers, or maybe more accurately, for applications to talk to other applications. So this API, real simple stuff, it's just these two calls right here. So we have our post call, which protects our data. We have a get call where we can pass in parameters on the URL if you want to. And if you're not familiar with URL parameters, basically you just do question mark and then the, like this case, message equals and the value. And if you wanted to have two parameters, you could have question mark message equals the value, then ampersand, and the next variable name equals in order to get those values. Okay? So message equals test, like so, and then ampersand ID equals 4 if you want to pass in the ID as well. So int ID equals 0 by default. Okay, so that's how you'd call this if you want to pass in both of those parameters. And that might be helpful for today's homework. But first, let's get to today's pro tip, which is to consider using an API for every application you create, even desktop applications. And I say this and people cringe sometimes because it's an extra layer to add, it feels like. But here's what I've seen. If you create an application, and let's just say you create a desktop application and you kind of put the code all together, maybe you don't even have a class library, the horror, but let's say you did that. And then your boss comes to you and says, that's an awesome application. How long until a mobile application is done? And you say, all the time? Like, I have to redo the entire application because everything has to be redone. The data access has to be redone. The business logic has to be redone and done differently for the mobile. And I have to somehow support that mobile application. And your boss says, once you get that done, your boss is like, that's amazing. We got a mobile application and we got a desktop application. But wait, where's our web application? And you go, oh man. And you go and do the same exact thing all over again. Or down the road, your boss says, ASP.NET MVC has served us well, but it's time to move to .NET Core. And while we're doing that, I think we should move to Razor Pages, which is a different UI. And so we're going to have to redo our user interface and our business logic and our data access code. And all of a sudden you're thinking, man, I wish I had some way of reusing this over and over again besides copying and pasting. Because if I copy and paste, now I have multiple bugs whenever I find one bug. An API solves most of these problems, if not all of them. You write the API and then create a user interface against it. Let's say it's a desktop user interface. You create that user interface and your boss says, how about that mobile app? And you go, it's just a user interface. And you create a new user interface that points to the same API endpoints that already have your business logic, that already have your data access, and you're good to go. And then you add the web page, no problem, we can do that. And you just do it by just writing the user interface. So APIs can be really powerful, especially when you have some sort of change in your future, whether it's from going to WinForms to WPF, or from one of those to a web application, or even to like a JavaScript single page application. All of these can be powered by an API and do so in a way that reduces your workload over time. So think about it. Think about the possibility of expansion down the road and if an API is right for your situation. Now, I'm not saying use an API in every application. Don't misread that. The first word is important. I say consider using an API for every application. I'm a big fan of APIs, and I think that they should be on the table for consideration for every application. But I don't think they're right for every application. So make sure you make that distinction. There are some times when it's just overkill, where you know this is where we're going to stay, and we don't need to have all that extra overhead, or we don't want to expose an endpoint that people can get access to. We want to have just our user interface as the only way to talk to our business logic and data access. In that case, don't have an API, but at least put it on the table to consider for every application you build. Okay, your homework for today is to build a web API application that has a GET call that takes in a first name and a last name and it returns hi, first name, last name. Notice it's a GET call, not a POST call, and then it returns the string hello, Tim Corey. Give that a shot, see how you do. Once you're done with that, come on back for the next lesson where we're going to do a mini project with Web API.